calculator, but it's going to be nasty. Okay. Yeah, I agree. Was there a part D to number 4? Yeah, part D is up here, sorry. The one hint I have as far as, weren't you guys supposed to get like multiple polar points or something like that? You have to be super careful that you're ending in the correct quadrant, right? Because if you're at pi over 2 and you, sorry. Well, that one, I guess either one, they're both positive 2's. You could have also been at positive pi over 2 with a negative 2, or negative 3 pi over 2 with a negative 2. Anyway, just make sure you're ending in the proper quadrant for the point that you're trying to locate. Maggie?
I got sine inverse because I did it.
Over 5?
I did because y equals 4. So I used y equals r sine theta, and I plugged in my r value that I got.
No, that should have been okay. So the r was still 5, negative 5, right? Depending on which one you were doing. And then you would have had sine inverse of 4/5, right? That's okay. Or you could have had cosine inverse of 3/5. That would have also been okay, because it's all pointing to the exact same triangle with the exact same angle. So you're okay with that. Any other questions on that one? Deba?
For b,
Yeah.
I just got confused on why there was a pi plus tan.
Oh, the reason they were doing that is because you were supposed to have more than one polar point, I think, that you were finding. Is that right? And so you could have, they decided to go 180 away and go backwards. So from whatever angle, like for instance, 4/3, or is it all positive 3/5? What point is this? B? Okay, so for point B, you're in the first quadrant. So what they did for the first one, the tangent inverse of 4/3, that would put you first quadrant, positive 5 goes out. But like you also could go all the way over to here, and instead of going towards that angle, you could go negative 5, and you would end at the same location.
So I understood that it was for negative 5 and the 5, but I understand for pi.
The pi was just because this stands for an angle, like a first quadrant angle. And so in order to do the negative, you have to get plus 180. But they're doing plus pi because it's radians. Does that make sense? The other way is that you could have done, it's just more awkward, but you could have done like something like negative 2 pi minus. I guess you could have done negative 2 pi minus and gone this direction. Sorry, positive 5. But it's easier to go 180 and then back. But it's pi. Okay, anything else in number 4? Part D? Yeah, it's up here at the top. Is that okay? You could have also done negative 2 pi. Is that what you're thinking?
Oh, yeah, negative 2 pi.
Careful. Negative 2 pi would have taken you back this direction though, right? Oh, are you just doing points on the circle? No, that's not the circle. It's a different one. You're doing D. So you could have done 0, 2, or you could have done 2 pi 2, or you could have done pi negative 2. Does that make sense? The negative goes opposite, like the opposite way of the angle. So if you're going towards the angle, always positive. If you're going away from the angle, always negative. Okay, sorry. The next one is number 14?
Yeah.
Okay. Number 14 was just, can you get it in your calculator? It was a 4-petaled rose. I know. Don't worry about the terms as far as the names of the graph. I'll peek at the quiz and see if it's on there. Anyway, it's called a rose. It's called a rose. A 3-leafed rose, a 4-petaled rose, a 6-petaled rose, a 2-petaled rose. I know it's weird. It's like a daisy or it's like a non-flower, but they just call them roses. Yeah.
So on the quiz, are you going to have to find the
There's no magic in these windows. They were just saying, can you get it to show on your calculator? They're showing you what their windows are, so you have a reference point. And your window could have been close to have a good picture, but there's nothing magical about those. So I'm not going to ask you to state a window on the quiz. It's more like, can you find the picture if you needed, if you were able to use your calculator. What's the next one? 24? Did you guys just figure out to make the r squared x squared plus y squared? It's a circle with a center of 0, 0, and a radius of 1. Where does the r squared equals x squared plus y squared come from? The four main formulas from polar to rectangular and backwards. What are those? R squared equals x equals y equals and tangent theta equals or theta equals tangent inverse of y over x. Either way. I don't like that one as much because tangent inverse won't always get you to the right place. Sorry, anyone listened to the video. I just thumped it. What's our, 29 gave you r equals 8 sine theta, right? Okay. They decided to be super creative and take the r equals, sorry, Mrs. Christensen changed the setting and I thought it was fine, but it ended up not being fine. They were creative. I wouldn't have been as creative. Well, I would have been. That's probably. Did I just close it? What did I do? There we go. So when they gave you, first of all, r. Now what? Is anyone else confused? Okay. So look over there. When r, look over here, equals, I give up. I don't know what to do. Okay, I'm going over here. When r equals 8 sine theta. Okay. There's no like easy property that fills in this. So they were like, multiply by r, multiply by r. R squared, I have something. R sine theta, I have something. That's great, and it works perfectly. But couldn't you also have just gone to your and couldn't you, wait a minute, I can figure out. It's easy. Sine and hypotenuse. So you could have also done r equals 8 I over r, just using your right triangle with theta. And then you could have multiplied r to the other side. R squared equals 8. No. And then x squared plus y squared is 8y. So this triangle can be a godsend if you don't like naturally see in your head, oh, multiply by r and it's y. That one's creative. It's out there. You can just use the triangle. Hannah. Oh, you can leave it implicitly. I mean, I would say leave it implicitly. I'm just going to get rid of that. In that, I would. Because see, they didn't get y by itself, right? Yeah. Oh, what do they ask? They ask for the center and for the radius? Oh, okay, so then you end up with yeah, if you were trying to find it, because then you would have your x squared plus y squared plus, no, minus equals 0. So you'd have to do your and then you could have gone ahead and dividing negative 8 by 2 and squaring it. 16 on that side, 16 on that side. You end up with y squared minus 8y, something that will factor to be a perfect square. So x squared plus y minus 4. So the center is at 0, 4, radius is 4. But that was only if you needed to identify. Otherwise, you would just be like, it's a circle, and it's messy, and I'll leave it to someone else to do. What's the next one? What's my function? R equals 12 all over, like that? I'm going to start with Zoom Standard just because. I'm I'm just going to do, no, I'm not. I would do zoom box, but my thingy takes too much time. 6 and then like 2-ish. So I'm going to go, I mean, if you're ever afraid it's not showing you a lot, you can always like include more angles. -6, I'm going to do like -8 to, it didn't go very far that way, to maybe like 2. It seemed to go down like -2-ish, so I'll go -3-ish to 3-ish. Huh. That's it. It's kind of like a flat egg, I think, right?
Is there a way to do it by hand?
You could do zoom square. What are we supposed to do by hand?
No, I was because I was trying to practice for it.
Oh, using the right triangle. You could have made cosine x over r. And then you could have simplified the complex fraction, gotten all the r's together, and used your r formulas to plug in. That's what I would have done. Huh? No, by hand. Not by hand. It's technically a version of the limaçon. It's a limaçon that can't go all the way into 0. Do we have any more evens, guys? Is that the weird distance formula one?
Oh yeah,
I didn't even know how to start.
Oh, it's so great, though. Distance formula.
Oh dear.
No, you're okay, because distance formula is... We're just typing it and didn't want to put a square root in. Of x2 minus x1 squared. We know the distance formula, or we've seen it before, right? Okay. You need x's and y's. So plug in r's cosine thetas and r sine thetas for each of the individual ones. So you go ahead and plug in r2 cosine theta 2 for x2, r1 cosine theta 1 for x1. Same thing for sine, just using sines, sorry, for y's, just using the y formulas. And then you could go ahead and FOIL. But the nice thing is the outer and inner, this is going to be -2, r1 cosine theta 1, r2 cosine theta 2. And this one's going to be, squared, sorry. Sorry. You're going to have cosine squareds and sine squareds. And the cosine squareds and sine squareds end up being 1 when you pair them up. Here, see? So you're going to have an r1 squared cosine squared, and then a r1 squared plus sine squared. You could pull those r1s out. Cosine squared plus sine squared is 1. That's why a lot of things disappear from there to there. So this guy had a cosine squared plus sine squared, which was 1. This guy had a cosine squared plus sine squared, which was 1. And then this is who was left. This is using actually a property from pre-cal, a composite argument property of cosine A minus B being, hold on, cosine A minus B, cosine the signs change, cosine with or together, which would be cosine A plus, is that, cosine A cosine B plus sine A sine B. Yeah, that whole thing was a composite argument property. Pre-cal. Yeah, I know. Long story short, it works. Yay, go team. Wow. Using a composite argument property from cosine A minus B from pre-cal, and using foiling, and using x equals r cosine theta and y equals r sine theta. You party poopers. Any odds that you got stuck on along the way? 39? 17? Okay, let's go backwards then. So 39, 25, and then 17. 39, I thought we already talked about that one, no? Oh, 29. Thank you. 39. I would have personally changed to terms of y and x using, it's not going to work. Sine is equal to y over r. Maybe it'll work if I open it again. It was worth a try. I'm just going to do this, so there's room. Okay. R is equal to -1 plus y over r, right? The struggle is if you tried to do this, wouldn't you end up with a nasty expression? Because this would be r squared. This would be -r plus y. You could plug this in for x squared plus y squared. That would be negative square root of x squared plus y squared. It's not pretty, but can you implicitly derive that function? Because the problem is, if you want the slope of the tangent line, you want dy dx, and if you take the derivative of this, it would be r prime of theta, which is dr d theta, which has, for us, no tie to that. I mean, it's related, but there's no way to take one and make it the other. There'd be a little bit of magic going on, I think, if you got the same answer. Yeah, Kathy. We will eventually this year learn a formula where we won't have to do the x's to y's. I was just seeing if you guys would go through and do it using your base knowledge that you had. But there is a formula that says that dy dx will equal y prime of theta over x prime of theta, but you have to find y using r sine theta, find x using r cosine theta, and then derive using basically product rules, but there's a way of memorizing what happens when you use product rules. So like Kathy said, there is a formula. We will learn it eventually. Now is not that time. I was just seeing if you guys would go make it implicit and then derive implicitly, but oh well, it was an E for effort maybe on my part. But you guys see what I did though, right? Transform and then take the derivative and then plug in. Well, you're supposed to be finding when theta is 0 and when theta is pi, so you'd have to go plug in x equals r cosine theta for each of those. So maybe it would have been a little bit intense, but it was possible. Okay, that was going back to number 25. So 39, there's nothing. Man, the computer's against me today. You guys see this? Okay, 11.3. We're going to number 25, right? Who was that? Deba? That was you? Oh, that was Hannah. Number 25. They did the whole creative thing again, in that they divided by r, and then they divided by r, and then the r distributed, and they're like, yay, it's pretty now. That's one way. The other way is that you could have plugged in right triangle, opposite over hypotenuse, y over r. Adjacent over hypotenuse, x over r. Then you could have simplified the complex fraction by multiplying by r over r. These, all the r's will go away, have x and y's. This will have a 5r, and then those r's divide away.
I just multiplied the sine.
You could have done that too. You could have just multiplied them up, bloop, and then distributed the r. And then all of a sudden it's pretty, and you can just plug in. Sorry, I wish my board was working better. That's a 5 on top. Does it make sense, the right triangle?
Yeah.
SOHCAHTOA. So y over r is sine, x over r is cosine. So you could have done y over r. Now I have these yucky r's. So to simplify the complex fraction, the way I do it, we would multiply by r over r. So then you have 5r all over, cancels out, cancels out. You can multiply him up. Divide. That's one way. Yeah.
Can you see what I did? I'm really confused.
Yeah. The other way, just to see if it makes sense, what Aryan did is he multiplied up on the other side. And then you have, just for anyone else who got confused, r sine theta minus 2r cosine theta. And then using those spiffy formulas, we can substitute with x's and y's. And then on yours, number 25, you were trying to plug into the x equals r cosine theta. So instead of putting x's and y's into the r formula, you were taking the and making parametric equations, x theta, y theta. We didn't want to make an x theta, y theta. We weren't going to parametric in this one. We were going to function or rectangle. So you were making x theta like x of t, y of t. You were making parametric with the formula, which is good if they asked that. But this one was saying, no, don't let the theta stay at all. Try to get rid of everything instead substituting for y's and x's. Does that make sense? Okay. And then the last one is number 17. Okay. Number 17. The snazzy name is lemniscate. That's how you spell lemniscate, or an infinity sign. And you were supposed to be getting the window. Was this one weird to see? I think you had to, on this one, make the angles like a bigger range. 0 to 2 pi wasn't enough to see it. Oh, they did negative pi over 4 to pi over 4? Oh. I think I did negative 2 pi to 2 pi, and I saw it that way. But the function was, what was the function? Okay, so then you would have had to do the square root of, right? Positive square root of, negative square root of. And it was r squared equals what? Sorry. 4 cosine 2 theta. So I would have done the positive square root and the negative square root because r squared has both. Huh? That could be. Yeah, that could be that. You just didn't see the other side. That's my guess. But I think you also needed to make the window go negative and positive for your angle values. You could have done like negative 2 pi to 2 pi, thinking that the 2 pi wasn't enough. Or you could have done like 0 to 4 pi. I think that would have worked also. But then that goes ahead and fills in. There you go. Just takes a while. It just takes a while. It's like a weird order that it goes in. But yeah, I bet it was the plus or minus square root was the big thing, and then you can change the angles to include more. Okay. With that, I think we've gone over the rest of homework questions. Homework should be graded and corrected, I think, right? Because we only had 2 homework sections. We're not going to check notes today just because of time, but go ahead and pass your homework spirals up. Make sure really quickly that your name is at least on the top of the first homework assignment, kind of like the heading over there. It could be on your spiral, that's fine. If it's on your spiral, we're okay. Just pass those up. I'm going to grade them while you guys take the quiz. Phones, go ahead and go up on this seating chart. Pause though, do you guys see the seating chart? It's weird, but this is row 1, so you guys are going to, in order of, this is going to be Eric, and then it's just going to go all the way over, right? And then Hannah and Riley are like right around here-ish, I think. And then the other, just put it in. It doesn't quite correspond to pre-cal, but first row, third row. Go on up, phones put in. You're going to grab your phones, not after you finish the quiz, but when you leave the room on the way out the door. And then clear your desk. Okay, homework spirals. Homework spirals. Oh, okay. Come back. Okay, so it's going to be late. All right, clear your desk of all but your stamp sheet. You guys shouldn't need scratch paper. Just grab out your stamp sheet, either a yellow or green stamp sheet or tutoring sheet. Aww. Go grab an extra and then just put it back after you finish the quiz. You can go grab an extra. Sally. No, Aryan's not in Sally's row. Aryan's not in Daniel's row. There we go. Okay. I know it's weird. It's like a quiz, it's not a full test, but it's only one side. As you guys can tell, I have like little graph grids. Answer places over to the right. There's space to work on the left. Oops. Calculators under your desks, not at your desk. And we'll see. There might be something where I let you, like for the last 60 seconds of class, pull out your calculator. But you don't have it at all? Okay, then you don't need it. We're good. I'm giving you a bonus. I'm giving you a bonus. Calm down. Don't worry. You won't get it. Not everybody brought it. I'm giving you a bonus. Calm down.